Hi everybody. In this video we're going to look at asynchronous programming. Now asynchronous programming is programming where some work runs separately from the main program thread and notifies the calling thread of its completion. So we'll get to understand this medium well by the end of this video. At least I'm hoping we'll understand it medium well. Before we do that, let's just kind of review something we already know, which is sequential programming, right? You're probably super familiar with sequential programming, but let's start with kind of an explanation of that, and that'll lead into this idea of asynchronous programming. And to do that, let's look at some program we already wrote, the program we wrote for the last video, FizzBuzz. And by sequential programming, I simply mean that it's programming that proceeds kind of not quite line by line, but pretty much sequentially through a file. And let me elaborate on that a little bit. So here in this FizzBuzz example, we started that for loop that I equals 1, I smaller than equal to 100, I plus plus. So our execution starts there, or kind of the equivalent in the compiled example of where it would be, interpreted example. And so now I equals 1, and then we proceed down to the next line and say if I mod 15, so I is 1, mod 15 is 1. So if 1 equals 0, it does not, so we just skip over that console log FizzBuzz, and we get to that else if statement there on line 7, and we say, hey, does I mod 3 equal 0? No, it doesn't, so I mod 3, I is 1, so I mod 3 is 1, so 1 does not equal 0, so we skip that console log fizz part. And we get to that other else if, and we get if I mod 5 is 0? No, it doesn't. I mod 5 is 1, so we skip over that console log, and we get to that else statement, and we do the console log of 1. And then execution starts again at the beginning of that for loop, so now I is 2, and we proceed down. So you can see that it's sort of stepwise, that we can kind of see the flow of control in this file. And I'm hoping this is a fairly simple example, so you get the idea of, hey, I understand what I mean by sequential programming. Let's look at a slightly different one, that compute Fibonacci numbers, the one we've already done. This is the version we used in that previous video, but let's just change it very slightly. It leads to the same results. So here is the function fib with the kind of a few new things added. It's a little bit more clumsy of an implementation. It computes basically the same thing, but I've added kind of some interim steps that I didn't really need. I could have done everything in that return statement, but it just helps with the explanation. So let's consider fib of 5. We're calling fib with the argument 5. We get to line 5 there, and n, which is 5, is not smaller than 2, so we skip that, and we get to that else statement. And then we get to line 8 within the else statement, so we are setting fib n1 to be equal to fib n minus 1. So at this point, part of the call stack looks like this, where we have n is 5, that's what we called fib with, and the program counter is line 8. Now, that's sort of shorthand. I'm waving my hands here. It's not, the program counter is really some location in virtual memory, but it's good enough for the purpose of trying to understand what's going on here to consider it a line in this file. And just as a reminder, the call stack is a part of memory that stores information about the active subroutines of a computer program. So it's keeping kind of track of where we are and what the values of things, of local variables are. All right, so we're in line 8 there, and we're going to call fib this time with n minus 1. N is 5, n minus 1 is 4. So we go away, we call the function again, this time with the argument 4. So 4 is not smaller than 2, that's line 5. We get to that else statement. We drop down into it. So we're setting that constant fib n1 to be the result of fib n minus 1. So at this point, the call stack looks like this, where n is 4, that's what we called it with, and that program counter is 8. So again, we're going to, that fib n minus 1, n is 4, so n minus 1 is 3. We're going to call that function again with the argument 3. 3 is not smaller than 2, so we get into that else statement. We execute line 8 again, this time inside a different call of that function, and the call stack looks like this, where n is 3, the program counter is 8. And again, we're going to call fib with n minus 1. N is 3, so n minus 1 is 2. So we call it, so fib of 2. 2 is not smaller than 2, so we go into that else statement. We are in line 8, and at that point, the call stack looks like this, right? So the n is 2, and the program counter is 8. Now we call fib one more time, fib n minus 1. N is 2, n minus 1 is 1, so we call it with fib 1. Now we're in the function, and we ask, is n smaller than 2? So 1 is smaller than 2, so we're on line 6, and the call stack looks like this. So n is 1, the program counter is on line 6. So now that function returns, so we can pop that frame off the stack, and then we finish the execution of line 8 there, and now we get n is 2, which it was before, but now we get this fib n1 instantiated with 1. And now we're on line 9, and we can execute that. So line 9 is, we're going to call fib n minus 2. N is 2, so n minus 2 is 0. So we call fib 0. 0 is smaller than 2, so we go into that if statement, and now we're at line 6. So now the call stack looks like this, where n is 0 and the program counter is 6. So that call of that function returns, so that disappears, and now we can process the result on line 9, fib n2, so that equals 0, and now total equals fib n1 plus fib n2, so total is 1, and now we're at that return statement. As we should see, the program counter is at 11. So now we can pop that function off the stack, and then we get here. So we can see that this call stack is kind of integral to determining the sequential order of how we're going through this code and executing statements. JavaScript adds something called an event loop. So if you can imagine you're in a browser and you do things like you're clicking stuff or you're typing into a text input box, JavaScript has what's called a message queue. So if you click on something, this onClick event is added to the message queue. If you type a letter into a box, onInput is added to the message queue. So all these things are added to the queue, and they're processed in turn. So the first onClick there, the one to the left, is executed, and that means it uses this call stack to determine the flow of execution within that onClick. So what happens in this design is that each message is processed completely before any other message is processed, right? So that first onClick, that all gets processed using the call stack, and then once that's completely complete, which is kind of a weird statement, once that is finished, then we do the onInput, get that all done, move to the next onClick, and so on. So we just kind of go queue entry by entry in this queue. And let me just give you an example of that. Let me just kind of interleave running the program and explaining it. So I have here a button, and when I click on it, there's going to be an onClick event. When I click here on the block for 5 seconds, that'll be an onClick event. And remember, there's this idea of a queue. So if I click this one and this one, this will be the first item on the queue, unless it finishes before I can click here. And this will be the second item on the queue. So just imagine that all these events that I'm doing, these are added to this message queue. And it's a really boring program because the only thing it does is I click this button and this counter will increase. And let me just click the button a bunch of times here, and you can see that it's increasing. Let me just show you that briefly in the code. So here I say there's an element called button or but, and I say add this listener. So if there's a click event, execute this code on but click. And the only thing this onButClick does is it increments the counter. So we see that the counter increments. And then this setBut message just displays it on the screen with this setBut message. So we get the element, this little div in the message or in the HTML. And then we set the content to be what's the message, which is the count. All right. Let me just click it a few more times for fun. That's pretty fun. And now, though, what happens is I'm going to click here, and as it suggests, it's going to put an onClick event in the queue, and then it's going to block for 5 seconds. But I can click here in this button, and it'll keep adding things to the queue. So let me just show you that. And now I'm clicking like crazy, and I'll stop clicking. And you can see that, yes, indeed, there are things in the queue, but as we saw, nothing is processed, or every event is processed one by one. Each event is processed to its completion. So when I click this block for 5 seconds, everything waits for 5 seconds until that whole event is processed. And let's contrast that with how things work in the real world. So I go to my doctor. It's like a follow-up appointment. Here she is, and she's going to check me out. And let's imagine that a doctor's visit works like the way I just explained things, how things work in JavaScript, that each patient is processed completely before any other is processed. So here I have this idea of a patient queue, Anne, Ben, Clara, and once someone's called in, then that person is processed completely before anybody else in the waiting room is serviced. So it works like this. So I go in there, and the doctor calls me into the exam room, and she talks to me for a few minutes and says, hey, you need to some x-rays. So she remember that each patient is processed completely before any other is processed. So she goes with me to the x-ray person, or we wait then for the x-rays to be done. And then she comes back with me into the room, and we're kind of waiting there for the x-ray person to get the x-rays back. And she gets those x-rays back and talks to me a bit. And maybe there's some other tests that need to be done. But she's with me 100% of the time before she moves on to the next patient. And you can imagine that's really the wrong way. And it's not the way it works in reality, right? The doctor isn't with you 100% of the time, contrary to this model I just gave you in JavaScript. She's more like the asynchronous thing I brought up in I think it was the second slide of the video, where some work runs separately from the main program thread and notifies the calling thread of its completion. So when she says, hey, you need some x-rays, then off goes some other program code that runs separately from the doctor code. And off I go and get x-rays, and she can go off and see other patients, do other things. And only when those x-rays are done, that separate program, she can note that program or that x-ray tech can notify, hey, I'm all done, here's the results. So that's how things work in the real world most of the time, contrary to how this JavaScript stuff works if we didn't have ways of doing this asynchronous programming. What's asynchronous programming? What I have listed here is the definition. Programming where some work runs separately from the main program thread and notifies the calling thread of its completion. So that's where we're going, and I think I just showed you why we want that. We don't want a user clicking on the interface and we ask, the user wants to stream something or get information, and then the whole interface freezes up while that user's waiting. So that would be one case with, hey, this doesn't work, this model. We don't want the interface freezing up. The user would find this unacceptable. And on the server side, if we're making a call to a database, and maybe the database is in some other location or just it's on a different machine, that doesn't take like 5 seconds like my block example gave, but it does take some time, and we don't want it to prevent us from doing other things. So that's why this asynchronous programming is so important in modern design. One way of handling it, or kind of an intro way, let's kind of wave our hands at defining what this is a system called callbacks, or a method called callbacks. And that is a function that is passed to another function as a parameter, and it's executed inside that other function. So a function that's passed to another function as a parameter, and that function will be executed inside that other function. It sounds kind of confusing, and I'm hoping it isn't, but let's give it a shot. And why do we want this? Well, part of it is that programming where some work runs separately from the main program thread and notifies the calling thread of its completion. So that's what we're trying to, in this little path of different options we have, that's what we're trying to get to. All right, so let's see how that works. One function we can use is this setTimeout function, or setTimeout function, which takes an argument, a function that we're going to execute, and an amount, an integer of how many milliseconds to wait before that function is executed. So let's see how that works. I have that function here. I pre-wrote it. So you see that in this function getData, I have a setTimeout function, and the callback function is defined here. And the only thing I do is I just repeat whatever the argument, this query argument. So I just print out that query argument, and this delay is given in milliseconds. So here in this function query is what I do. So I say get data 3000, which is the milliseconds, so it waits 3 seconds. And then the other argument is the string unicorn store. So this get data will wait 3 seconds, right? That's this argument 3000. And it'll console log unicorn store. Next, on line 12, I say log A1, just the string. Then I get data with 1000 in Captain Marvel, so 1 second in Captain Marvel, and console log A2. Okay, so and here's this query. So the question is, what do you think is going to be printed here? In what order are things going to be printed? Do you think it's going to be printed Unicorn Store A1, Captain Marvel A2, or some other arrangement? So you may want to just pause the video or at least quickly think, hey, what's going to be printed? And let's give this a shot. All right, here we go. Let's see if our intuitions hold. So I'm going to call node sleep 7. So it's A1, A2, Captain Marvel, Unicorn Store. So did that match your expectations or not? I guess maybe the first time I ever did it, it didn't match my expectations. So what happens here? So here we have this get data 3000 Unicorn Store, and we set timeout. So it's going to run this function 3 seconds from now. So next what happens is it console logs this A1. So it prints A1. Then it says, hey, run a function, this get data function with 1000 Captain Marvel. And so it's going to wait and run this console log, this function I didn't give it a name. It's going to run console log and Captain Marvel. So it'll run this function that I didn't give it a name in 1 second. And next we do this console log A2. So A1's printed, A2's printed, the timer goes off, that 1 second timer, and Captain Marvel is printed, and then that 3 second timer is set, and we print out Unicorn Store. And that's what we saw here. So that's cool. So now we're getting things kind of in a more interesting order than just sequentially, and we can see what, this is kind of a dodgy example of just timing out, but we'll see this has really good functions or really good utility later on. That utility is this. I'm trying to kind of fake it a little bit by using this get data. And the idea is here that things may take a bit of time to get from a database server, not 3000 or not 3 seconds, not 1 second, but some time. And we don't want to have everything stop while we're waiting for a database server or some other aspect of the program to complete. A more interesting example is this one. This function read file in JavaScript takes as arguments a file name, the attributes, so is it a UTF-8 file or what's other attributes we have, and then a function. So once it finishes reading, it'll execute that function. Again, that's the definition of a callback function. So let's take a look at how that works. So here it is. Here's that example. So I load in that module, and here is this function that we're going to look at. It's process file that I wrote, and we use that file system function read file. And it takes as arguments, as I just described, a file name, some attributes like the encoding is UTF-8, and then it takes a function. So once it reads that file, what to do next. And here is that function. And let me just kind of explain it briefly. It's in that arrow format that we talked about in the last video. And there's 2 arguments in arrow 1. So if there's any error in reading the file, it'll send information there, what the error is. And the data of the file will be put in this data argument. So there's 2 arguments, an error data or an error argument and a data argument. And here's that function. So if there is an error, it'll log that error. Not very cool, but it'll be not very interesting, but it's just an example. And if there's no error, it's just going to log that the processing's complete. I didn't want to print out that file because in order to do this with a file that's reasonably long, it would be a long text string. So I just wanted to print out processing complete. And so here's what I'm doing. I'm just printing out A1. Then I do this process file. And it's going to read that file, and once it reads that file, it'll execute this function here, this arrow function. And once it reads that file, as long as there's no error, it'll print out processing complete. And then it'll console log A2. Or no, I shouldn't have said then. There's also on line 17 this function console log A2. And now the question is again, hey, what do you think? What's the order of these things? Will it print A1? Processing complete A2, or will it do it in some other order? And let's see if your prediction is the correct one. So you see it took a while to load that file, and it didn't wait around. It kept going and it printed out this. So this processing of line 16 here, analyzing this glove data set, didn't slow down execution, right? We just said, hey, when you're done reading it, execute this file here. This is that file. I said, hey, execute. And then I could go on with my main flow of execution. So that's really cool. And that's callback. And that's all basically we're going to do with these callbacks. Callbacks get kind of tricky to write. That's the problem with callbacks. They get a little bit convoluted, and you get they're a little verbose in that, there's a lot of code you might have to write. The other thing, it's very difficult to cure, is that these are a bit recursive, not in the recursive Fibonacci thing, but if one thing is sort of asynchronous, the calling function may have to be asynchronous, or at least know about these asynchronous functions. So it's kind of tricky to get these things in the right order, or to think about things in an asynchronous way. The next thing we'll look at are promises. And what promises are, they represent the future result of an asynchronous operation. Again, kind of hand-waving, what the heck is that? But we'll learn and get kind of a sense of that. So these, I think, are more popular on the browser side. So if you're working with something like in React or something, I think you'll be using promises a lot more. You need to understand promises regardless of whether you're doing server code or browser code. But we have other ways of doing things on the server side that may be a little bit easier to understand. So promises represent the future results of an asynchronous operation. And here's how you use them. And the first thing is, if we have a promise-based function, so I'm starting with kind of the easy thing of how to use a promise-based function. So let's say this DB query is promise-based, and it has these arguments, a query in millisecond, like we've seen before. This then part, as I mentioned down here, registers callbacks that handle results. Okay, so here's basically how it works. So when you call DB query, what's returned is something like, hey, I'll get back to you, just kind of a promise. Got it. What you gave DB query is this callback saying, when you get a result, please use whatever I tell you to do in the then clause, that arrow function. And if there's an error when you're executing, hey, DB query, if there's an error, do this other function. So you're giving it two functions. One registers the callbacks that handle results, and the other is the one that handles errors, right? So if you get results, once DB query is done and there's results, it's the function that's going to run is this one that's in this then clause. So that's fairly easy to do. So let me give you a demo. Before I give you a demo of that, of how promises work, let me give you kind of the non-promise, non-callback, non-anything version, just to see that, hey, I can see what the problem is and why we need to deal with this asynchronous code, which seems like a big headache, but at least now I'm hoping you'll start understanding why you need to have these headaches of trying to work with asynchronous code. So let me give you a demo. So here is, I think, enough code that we can understand it. So this function just implements sleep. So sleep 1000 will just wait 1,000 or 1 second. And I'll start down here at this doit function. So I call doit. It does this DB query, and then I just fake a query because I think this is what we'll be using with Postgres. And so I'm just trying to make it and give you some motivation of why you'd need this. Postgres is fast, but it's not instantaneous, and you may want to do other things. You just don't want to wait around for a response from the server or any other database server or other things you may want to use. And so I'm just trying to motivate this example by being as close as possible to something that looks kind of databasey. Bear with me. So here I'm saying, hey, select unicorn, and I give it a millisecond how much time to sleep, and then I log B here. And then I do select Captain I do this DB or query DB, select Captain Marvel with the 1000 argument, and then log C. So query DB is here, and that does something very simple. That just executes this DB query command, and DB query just sleeps however much time I want to. And then if I say select unicorn, just return that unicorn store, else return Captain Marvel. Once that returns, this function query DB just prints out that result. So have a look, and what do you think is going to be printed? So I do select unicorn, B, I print B, select Captain Marvel, and C. And this is called sleep sync, so let's see how it works here. You didn't need to know that was called sleep sync, but if I want to execute it, I do. So it's Unicorn Store, B, Captain Marvel, C. And you can see that it delayed quite a while. So if that was an actual select statement going to a database, again, it's not going to be 3 seconds, but it'll be some time. So before I can do this B, whatever that might be, it has to finish this. So it's going to print out Unicorn Store. It's going to wait 3 seconds, print out Unicorn Store, then print B, wait a second, and then print Captain Marvel, and then finally print C. So you can see, I'm hoping that motivates you of, hey, it'd be nice if it didn't do that. Let me just run it again. All right, so let me get to my promise-based example, and that's this one. This is exactly, now we're paying attention to kind of lines 13 through 19. I'll explain the ones above it in a second. But this is that then. So I do a database query, I get the result, and once I get the result, I'll print it. So that's the then, right? I'm registering a callback function with this then. So if there is a result, if there's an error, just print that error, right? So this is the same. The difference are in these functions, and you can see that I'm giving a callback functions. So let me just show you what that does. So it was different from the other one. How is it different? So it prints BC, Captain Marvel, Unicorn Store. So when I do the query DB, it comes up here. It's based on promises, so it doesn't wait. You know, DB query returns, just says, I'll get back to you. That's what the return basically is saying. And just it says, this function knows that, hey, when I actually get results from DB query, I'll execute this, whatever in this then part. So it returns almost immediately. So we print out B. I do it again with this Captain Marvel, and so I print out C. And once I do get results back from this Captain Marvel thing, which is only 1 second long, it'll print those. That's what's in this then clause. And then eventually when I get some results back from related to the select unicorn, there's this then part, which is a call. We're registering a callback. Once results are returned, execute this callback function. So that's promises, or that's how to handle promise-based functions. That's sort of the easy part of promises. And here's how to implement a promise. So what we have here is the first thing we do is we're returning a new promise. So what a promise takes are 2 arguments, this resolve, which is something that delivers results, and reject, which is delivering errors. So it kind of matches how we are on the receiving end, right? We had the then clause, which registers a callback for the results, and a catch statement that registers a callback for errors. So here we have kind of an equivalent thing of resolve and reject. So if we have actually results, we just put the results in this resolve function, resolve, and then whatever the results are. So that's how to implement one. We just say we create a function that returns a new promise, and we need to write a function that uses resolve and reject in order to, for these callbacks to handle them. And that's up here. So we return the new promise, resolve. And here's where I'm getting a little kludgy, because I'm just using a set timeout to delay things. Normally there would be a built-in delay. I'm just kind of faking the delay with timeout. But here's how it works. So I'm just using resolve in this case. So I set a timeout for whatever milliseconds it has. And if it's a select unicorn statement, I'm going to resolve or return unicorn store. And if it's not select unicorn, I just return Captain Marvel. And remember, this then registers a callback. So once this resolve does create unicorn store's output, then it's going to execute that then part. I gave you that example before, but I'll just run it again. So that's promises. So that's how to handle promises. So we need a .then, and a .catch, and we have, this is the format for creating a function that uses, it's a promise-based function. Finally, I'd like to look at async functions, and they're the easiest to use. They're the ones we're going to be using mostly on the server side. You need to understand promises to sort of understand how async works, but you don't need that in-depth knowledge of promises that you'll get kind of on the frustration side if you're working with React or doing other things, or at least that's my experience. Maybe others have other experiences. So I think they're the easiest to use. So let's see how that works. So that's here. This, in order to do it, I created this. It's the same promise as before, but here you see we don't have .then and .catch. We have an async function. So on line 13, we say, hey, this is an asynchronous function, meaning don't wait for me to finish, right? Just return. It's going to just return something. And here's where I wait. So when I'm awaiting on a promise-based function, this do query. So I just say, wait for this DB query to finish and then do whatever. So it's like where I'm going to hang out on this line 14 until I do get some results, and then I'll execute the next one, which is 15. But in turn, don't forget, because I put this async here, it means that the function that called it doesn't wait. So again, let me try to explain it once more. It might be complex, or in my brain it seems complex, which is that, so these async functions, you just stick an await before when you're calling a promise-based function. So this whole query DB kind of hangs around waiting for DB query to be done. And once it's done, it executes the next statement in line, which is line 15 here. But an async function, whatever called the async function, doesn't wait around. It just keeps going. So if I called query DB, once it's an async function, I don't wait around. I just execute whatever is next on my list. So down here in line 20, I called it. It's an async function. I don't wait for it to finish. I just execute the next statement, console log B. Then I execute this query DB. It also calls that async function. Query DB is an async function. So it doesn't wait. This function doit doesn't wait for query DB to finish. It just keeps going and does that console log C, right? These async functions are waiting around for DB query to finish. And once it finishes, it'll go on to the next line, which is the console log result. So let's see how that works. So it prints B, C, Captain Marvel, Unicorn Store. So again, right, it hits this query DB. It's an async function, so it doesn't wait around. I mean, this query DB is executing, but this doit function doesn't wait for the results to be returned. It just goes on to the next one. So we print B, again, another query DB. We don't wait. We print C. Captain Marvel is only waiting 1,000 seconds. So we're waiting on here. DB query for the Captain Marvel one finishes, and we print the result, which in this case is Captain Marvel. And finally, that first one that we execute, query DB, that one finally finishes. We are here waiting for await query DB to finish, and we print out then Unicorn Store. So that's it. I'm hoping it was somewhat understandable. To me, when I first learned it, it was kind of confusing, especially the promise part. For some reason, the async await made sense to me. But as I used it more and more, it got more and more clear, I think. So when you start using it, it'll start making more sense to you, I think, and realize that you don't instantly get results. So we covered what asynchronous programming is. We covered this callback function idea, this idea of how to handle with promises, and especially the .then, .catch kind of syntax. And finally, we covered these async functions, which is the asynchronous programming construct we'll be using throughout this course. I hope it was all helpful and not like too totally confusing. See you in the next video. Bye.